Here we're going to look at the fair price to pay for playing a game and fair games. When we talk about the fair price to pay for playing a game, what we're talking about there is that the cost to pay for playing the game will equal the expected value of the game. That is, what you pay to play and what you expect to get back are the same. Let's take a look at one of those. 3 face cards from a deck are placed in a box. A player draws out one card with the following payouts. If he draws out the jack, he gets $2. If he draws out a queen, he gets $3. And if he draws out the king, he gets $7. What is a fair price to pay for playing this game? The fair price to pay is going to be the same as the expected value. So we are going to set up an equation to find the expected value for this game, and whatever that expected value is, that's going to be our fair price to pay. Expected value. So that's the probability of each event multiplied by the result of each event. There are 3 cards in the box. Each one is equally likely. So the probability of me getting the jack is 1/3. And if I get the jack, I come out $2 ahead. The probability of getting the queen is 1/3. And if I get the queen, I come out $3 ahead. The probability of getting the king is 1/3. And if I get the king, I come out $7 ahead. Now I just need to simplify this to find the expected value, and I'll know the fair price of the game. So I multiply 1/3 times 2, and I get 2/3. And I multiply 1/3 times 3, and I get 3/3. And I multiply 1/3 times 7, and I get 7/3. And I add those together. I've got a common denominator, so I can go ahead and add them. And I have 2 plus 3 is 5 plus 7. So I have 12/3 as my expected value, which 12 divided by 3 is 4. And we're talking about in terms of dollars. So the fair price to pay for playing this game, which is the same thing as the expected value I expect to get back, is $4. Next, we're going to talk about fair games. The key here is that a fair game isn't one that the player always wins, isn't one that the house always wins. The key to a fair game is that the expected value of that game is going to be equal to 0. Let's look at how we can create a game and make sure that it's fair. A poker chip is drawn from a bag that contains 3 red and 2 blue chips. If a red chip is drawn, the player loses $6. In order for this to be a fair game, meaning the expected value equals 0, how much must a player win for drawing a blue chip? So here what I want to set up is I want to set up my equation for expected value, and let's see. The probability of drawing a red, well, let's see, there's 3 red and 2 blue. So the probability of drawing a red is 3 out of 5. And if a red chip is drawn, the player loses $6. So if that happens, we're going to lose 6. To set up the rest of my expected value, let's see, there are 2 blue chips out of 5. So the probability of drawing a blue is 2 out of 5. And then what happens if I draw blue? Well, that's what I don't know. That's what I'm trying to find. How much must a player win for drawing a blue chip? That's the thing I don't know. So I need to use a variable here, and we'll call that x. Now I've kind of got an equation set up here, except I don't know what the expected value is, so I'm not sure how to solve it. Wait a minute. The problem tells me that I want this to be a fair game. So that means that my expected value has to be 0. And so now I've got an equation set up where 0 has to equal 3/5 times -6 plus 2/5 times whatever x is. And I'm just solving for x. That's what I want to find out. How much must a player win for drawing a blue chip? So we'll continue. I'm going to go ahead and do some simplifying here and multiply 3/5 times -6, so that's -18 fifths, plus excuse me, 2/5 times x. Now I've got an equation with one variable that I'm going to go ahead and continue to solve. I'm going to move over here to continue, and let's see, I'm going to add 18/5 to both sides so that I have 18/5 equals 2/5 times x. And now let's see, I'm trying to get that x by itself. So I've got to get rid of that 2/5. So on the right hand side I need to multiply by 5/2, because when I do that, these 5's will cancel, these 2's will cancel, leaving me just the x. Now if I multiply by 5/2 on the right side, I also have to multiply by 5/2 on the left side. And you can do this a couple of ways. I'm going to go ahead and cancel those 5's that are in the top and bottom, and I wind up with 18 over 2, and I can simplify 18 over 2 to just be 9. And the question was, how much must a player win for drawing a blue chip? Well, I just found that out because that's x, and in order to make this a fair game, a player must win $9 when drawing a blue chip.